morning, afternoon, evening, wherever you are on this globe, and welcome everybody to our second series of oil and gas related webinars. Today we have an array of speakers. We have Prasanth Sreekumar, Arjan van Ginkel, and Jens Hundrieser to talk on the topic of hydrogen and oil and gas. So you better get used to some of the various accents speaking to you. So a small introduction. Prasanth is the global industry manager for our gas business, working in our corporate services in Switzerland, but living in Dubai. He is also the leader for one of the strategic directions for the global oil and gas industry development group with Endress Hauser. Arjan van Ginkel is based in the Netherlands. He is the local oil and gas and chemical industry manager, and is also leader of a strategic direction within the global industry group as well. And last but not least, we have Jens Hundrieser. He's located in Germany and is the industry manager for power and energy in Europe, and heavily involved in the hydrogen topic as well. So this webinar will last roughly about 45 minutes, 30 minutes presentation, 10-15 minutes questions and answers. And my name is Rob Vermeulen, and I am the global industry manager for oil and gas at Endress Hauser, and I'm located in Greenwood, which is close to Indianapolis in Indiana in America. Before we start, I like to have a safety moment, as is a custom in oil and gas and also at Endress Hauser. And today I like to focus on the corona crisis. Please wash your hands on a regular basis. Keep at least 6 feet, 1.5 meters distance from each other. Wear a mask in public. Avoid coughing in public, and use a natural tracking app when available, because it's, I think, critical that we all keep safe and healthy. Now, a small introduction of Endress Hauser. Maybe you can, yeah, thank you. Endress Hauser is a global company employing roughly 14,000 people worldwide and has a revenue of 2.6 billion euro. Our headquarters is in Basel, Switzerland, and our core business is to develop, produce, and service laboratory instrumentation and process instrumentation to measure quality and quantity parameters. We own and license roughly over 8,000 patents. So, with this, I would like to hand over to our first speaker of today, Arjan. He can introduce himself. He's also Dutch, so the change in accent is not that much, because I'm Dutch myself as well. So with this, Arjan, the floor is yours.
Thank you, Rob. Hello, everybody. Can we please go to the next slide? Welcome. So we have a presentation about hydrogen and oil and gas. Why hydrogen? Well, we have climate objectives for 2030 and 2050. We want to reduce the greenhouse gases by 2030 by 40%. We want to have more green energy use, and we want to have a more energy efficient production or life as we have it. So the green hydrogen, we actually see it like this. We see the green electricity as the future energy source for our globe. Since the peaking moments are not always at the same time, so we have the sun shining and the moment we need the electricity are not equal, we need to store the electricity. Storing it in hydrogen is a very favorable way, because we have an existing gas infrastructure. We can store it in there. We can easily convert it with electrolyzers into hydrogen gas. And hydrogen gas is also a feedstock for industrial processes, like in the chemical or in the glass industry. Hydrogen may also be stored in different forms. So it can be stored in a gas, a cryogenic, or liquid form. Liquid form would be liquid organic hydrogen carrier. It would be a methanol, an ammonia, or a formic acid. Those are the best known at the moment. Today, we will present in 30 minutes our hydrogen compatibility as Endress Hauser, and this is especially focused on the hydrogen production and distribution. So after my introduction, Prasanth will talk about the refinery application, steam methane reforming and pressure shock absorption, and about liquid hydrogen storage and flow metering. Then I will do a piece on the newly arising I say because it's not new, carbon capture and storage, and Jens will and with the focus on the different electrolysis technologies. Next slide, please. So hydrogen is actually, as we said, it's on the one hand side, we can use it as an energy. On the other hand side, it's also a use in chemical or glass processes or in the gas industry. Also the different gases. So there is what we call a sector coupling going on. This means that the focuses we have for the objective for 2030 and 2050 are not only for the electricity or the energy industry, it's also for the food, it's for the life science, it's for the chemical, it's for the transport sector, and also the heat sector. So what we need to find is different ways to connect these industries to exchange power in different forms, to exchange heat. And therefore we say it's a sector coupling where you have multiple different companies working together, supplying each other with gases can be exchanged, and in that process we try to minimize the CO2 emissions. Please click. Hydrogen, we know it in different formats. We know it in gray, blue, green, pink, and maybe some other colors that people may define. Gray and blue are hydrogen that's being created from a methane process. A methane conversion. So this is where Prasanth will present about, and then the blue is the part where the carbon will be captured and either reused or stored. Green hydrogen is where we take green electricity, we put it in an electrolyzer, alkaline or PEM, and we have the green hydrogen. And now I kindly give the word to Prasanth to present the, one more slide for me, sorry, missed it. The hydrogen European strategy, as you see here, the European Union has set different strategy, or has set a strategy for in 3 phases from 2020 to 2024, from 2025 to 2030, and from 2030 onwards. The focus is about generating enough power to convert in the end 2 times 40 gigawatts of hydrogen, renewable hydrogen over electrolysis process. The cumulative investments are expected to be up to 470 billion euros, and the expected gains after 2050 in the trading will be with a turnover of 630 billion euros. So there's a lot of money involved and a lot of jobs involved. And as we have this for Europe, we also have this in other world regions, so China, Korea, Japan, South America, USA, Australia. Everybody has its focus on hydrogen. So hydrogen is really a relevant topic for us for the future. Then I kindly give the word to Prasanth now.
Thank you, Rob. Thank you for the introduction, and Arjan for introducing the topic of hydrogen. Arjan talked about different colors of hydrogen moving in from gray to blue to green. My part of the presentation, I'll try to cover the gray part of hydrogen, steam methane reforming, and pressure swing adsorption. In terms of production of hydrogen, these technologies are there in place since last many decades, whether it is a hydrogen feed coming into a refinery or a feed going into a chemical plant, you have steam methane reforming process. What I'm trying to explain here is a very simplified process diagram for steam methane reforming. Basically, I have simplified into 3 different steps. Step number 1, where methane rich natural gas combines with steam at elevated temperatures in the presence of catalyst, converting that to hydrogen and carbon monoxide, which is called as syngas. Second step of the reaction is carbon monoxide combines with steam to form CO2 and H2. This is primarily what we call it as the water gas shift reaction. And the last step in terms of this process is pressure swing adsorption. This is where you have the hydrogen at the highest purity level that is possible out of PSA. In terms of portfolio from Endress Hauser, we offer a complete portfolio for SMR and PSA process. What you see on the left top where my cursor is steam and natural gas flow. Vortex flow meter, globally accepted flow meter for steam flow measurement. And what you see on the right side is our process ultrasonic flow meter for natural gas flow measurement. As we come into the right side of the slide, pressure and temperature transmitters, we offer a complete range of pressure, differential pressure, and temperature transmitters. One of the critical topics when we talk about pressure transmitter hydrogen is the suitability of the diaphragm, the membrane, what we use. We have devices with gold plating, so which is suitable for hydrogen application. Coming to the left bottom, what you have here is the fuel gas and the hydrogen flow. The technology which we offer for these kind of applications, Coriolis mass flow meter or a Vortex flow meter. And the last topic which I would like to highlight here is the composition measurement. Here, what I'm showing here is the composition measurement of hydrogen, which is really critical in terms of understanding what purity of hydrogen we are having from the pressure swing adsorption. I will come into detail of some of these devices and application in my coming slides. I'll start with a Vortex flow meter, universal flow meter. Whether you have an application for liquid, gas, or steam, Vortex can be used. One sensor for all different line size. That is the sensor what you see in here. We have a capacitance device where in terms of having multiple sensors in your stock as part of your inventory, that can be avoided with our sensor design where one single sensor fits all different size of Vortex flow meters we offer. Lifetime calibration, what does that mean? Number of the Vortex flow meters that comes back to our factory for recalibration. We found that there is high stability in terms of our factory calibration, and only applications where there is high erosion or corrosion possible and there is a reduction in the inner diameter of the shader bar, those are the areas where we see some shift. But in terms of standard steam, gas, other liquid applications, lifetime calibration. Some other features on our Vortex flow meter: extremely robust against temperature, vibration, water hammer. Water hammer is a constant feature when we talk about steam application, and we have devices which can cater for high pressure application. What you see on the right side on this slide is wet steam detection, quality of steam. With our Vortex flow meter up to meter size 4-inch, we can do wet steam detection and also give you a message in terms of the quality of the steam what you have in your pipeline. Moving from Vortex flow meter to ultrasonic flow meter, this is our new process ultrasonic flow meter which we launched last year. Some of the key features on this device is SIL 2-3 rated, compliant to IEC 61508. As you see in the picture here, the device comes with integrated temperature and pressure devices, advanced gas analysis based on the speed of sound. For a non-composition of gas, we can do calculations in terms of the energy content, the calorific value, Wobbe index in here. One of the unique feature of this device, based on the biggest challenge the process industry is facing, the ability to measure wet gas conditions. In a gas line, roughly around 5 to 6% liquid volume fraction, this device works quite well, and this is made possible because of the advancements which we made on the sensor design as well as in terms of the signal processing. In terms of the calibration of this device, these devices will be calibrated in an ISO 17025 gas calibration rig in our facility in Switzerland. And last but not the least, these devices are equipped with heartbeat technology. What I'm trying to show in this slide in terms of the hydrogen purity is basically out of an SMR, you can have a high purity composition and a low purity composition. What I mean by high and low, you can refer that to the percentage of hydrogen. What we have here is a 99.941% hydrogen, and on the low purity composition, it is a 99.025. What you see on the spectrum here is a spectrum out of our Raman analyzer. I will come into detail of that in the coming slides. The picture what you see here is this is an installation in a refinery in US where our optograph, which is based on Raman spectroscopy based on scattering principle, is installed, and what you have from the PSA outlet is the numbers what you see in here: hydrogen 99, methane 0.5, nitrogen 0.4, and CO2. Another application in PSR process where since you have elevated temperatures in a water shift reactor, there are some measurements which will need some sampling system. This is one installation with a DRS sampling system. To explain this better, I think I will go into the next slide. What you see on the right side here, an opto AST sampling interface and an opto DRS process sampling interface, primarily to get the sample out of the line, which is at elevated temperatures. Then you have an airhead fiber optic probe, which goes into the line. What you see on the left side is our control unit or the transmitter of optograph. And what you see on the center, it's an optogram. Look and feel of things looks very similar to a gas chromatograph. Moving in from steam methane reforming to liquefaction of hydrogen. If you have to transport hydrogen to different parts of the world, there are projects which is currently in place happening in Australia, in Japan, where you have coal gasification hydrogen, then liquefied by cooling hydrogen down to minus 252 degrees C. Then you have liquid hydrogen with high concentrations of energy. The steps involved in hydrogen liquefaction, step number 1 is compression, followed up by cooling. And the last step is expansion with the help of a Joule-Thomson valve. And the picture what you see on the center, this is one of our servo gauge, which we installed on an inland facility where you have LH2 in the tank. We also have installed another servo gauge on a marine vessel, which will be transporting liquefied hydrogen from one part of the world to the other. This slide explains metering solution which we offer. Endress Hauser, we do the complete design, engineering, fabrication, and supply of metering solution for hydrogen. You see in the picture in here, you have all the piping arrangement, valves, you have an Coriolis mass flow meter, temperature transmitter, pressure transmitter, all wired up to a flow computer. So we have experience supporting working on metering solution as far as hydrogen is concerned. So with that, I will hand it over to Arjan to talk about carbon capture, utilization, and storage.
Thank you, Prasanth. So what we say is that we want to decarbonize our world. That means we want to have a CO2 neutral environment. Of course, green hydrogen would be a very good solution in that direction, but short term, it's not really what is possible. And we already have seen this discussion going on for the past 10 years around carbon capture and storage. It became a very high topic around 8-9 years ago. The EU gave away subsidies for it. From that, we saw different projects, and also before it, we had the Sleipner project in the North Sea, the Kato P18 storage, Snøhvit in the north of Norway. Different projects where CO2 was captured in a refinery process, either pre-combustion, oxy-fuel, or post-combustion, like a scrubber solution, and then it was taken offshore, stored there. Now, when I say it's newly arising, it means like for the short term, green energy is not really the solution. If I take a publication from Tata Steel, which was very recent, they say that if they would completely decarbonize and would only go for green energy, they would need about 70% of the plant's wind turbine capacity in the North Sea. This equalizes 6 gigawatts of power they would need alone. And with that, we have a lot of other companies as well that need power. So for the short term, it's not a solution to go directly to green. They also find a solution into the CO2 capture and storage offshore. Here in the picture on the right-hand side, you also see a project which goes on with ExxonMobil, Shell, Air Liquide, Air Products, GasUnie, IBM, and the Port of Rotterdam authorities, where they want to capture CO2 from the processes, both in a post-combustion scrubber solution and an oxy-fuel solution, and then put it in a pipeline, then pump it offshore, and then store it in gas, depleted gas fields. Now, CO2 is known. We also use it in the food industry. It's known applications. Also in these applications, the current portfolio we're having today, you can use on CO2. That is for the different applications. It's for the capture, it's for the storage, either in liquid form, gas form, or in supercritical form. You can all measure with the instrumentation supplied today. Then the storage, we have it in the empty gas fields. We also have storage as we know it in enhanced coal bed methane. It means we pump down CO2 into a coal mine, then the CO2 ties itself into the coal, presses out the methane, and then we capture the methane at the top. Of course, this is a very interesting way to get the energy out of the coal, but it also goes over high pressure, so it causes earthquakes in certain regions, and people are not very happy with that. And we have quite some experience with it in the Netherlands. It's not pretty. So it's not really that popular, let's put it like that. Next slide, please. And when we talk about the custody transfer, and when we talk about the Shell and the Exxon and the Air Liquide making a connection to the pipeline, they actually make a connection in that moment. It's a custody transfer application, so they have to calculate how much you're injecting into the pipeline. We have known experience in this. Like I said, it's not a completely new market, it's newly arising. There's the established technology which you can use. In this case, if it's a custody transfer, it's OML R137 gas flow meter, or the MID MI002, which is applicable, where you have a gas flow meter and a gas flow computer. Two different parts which need the individual type approval, but you do not need a system approval like you need with liquid measurements. This also goes for the supercritical phases. So most of the gas is done in supercritical or in a gas phase, and then the gas regulations apply. So when you have any further questions on this, you're happy to contact us and ask more details. Then now we turn to Jens.
Yes, Arjan, thanks for handing over. Thanks, Rob, for the introduction. It was mentioned several times, decarbonization is the main target. And it was also shown on this slide. Can you push one more further? The coupling, one more, please. The coupling of the different industry sectors. Steel was mentioned there, 100% decarbonization is possible, but it takes 30 years or even 50 years to completely change it. Other topics are cement. So the key issue is here starting with renewable energy and then coupling the different sensor with different storage areas. And this is only one example we speak about today. Decarbonization is not happening overnight. It's happening in several years. I'm responsible for the power and energy industry. And you see in different countries, you see a fuel switch from coal to natural gas. And then at the end, there are already existing some gas turbines who could handle pure hydrogen if there would be enough hydrogen. At the moment, there's not enough. So let's have a look more into details to the power to gas topic. And here I like to explain one more, please. One next, please. That from the fluctuating energy that we have, so you have wind, you have solar, and some countries, even in Germany, which is not so much known as a very sunny and very windy country. The new statistic shows that by half of the year, 50% of our energy comes from renewable, from wind and solar. Now you have green hydrogen via electrolyzers, where I'll go a little bit more into detail. And here you can see on the graph why power to gas is seen as a system solution because now you can use it directly in different industry sectors. Arjan already mentioned steel sector, refineries need hydrogen, chemical needs hydrogen, so there the hydrogen can be used. Hydrogen refueling station, they can be directly connected after different compression phases. In some countries, cars in Asia, for example, cars are booming. In Europe, it's more trains, or in US, trucks. So this is also hydrogen-wise possible. A huge opportunity is hydrogen using the natural gas grid, the pipelines as a storage. There are also discussions and exams are ongoing at the moment. It's limited to a little bit less than 10%, depending on the countries. But the consumer tests are ongoing if they can handle 20%. So hydrogen is then given to the natural grid. If you have biogas plants or other source of CO2, you do a methanization, electricity generation, which I mentioned also. When there would be enough, you could give it to gas turbines, and at the end, even for households. So hydrogen, green hydrogen, offers so many options for converting it to all different areas, that there's a lot of project now started. And Arjan also mentions it. A lot of countries have their national hydrogen strategies where several billions are invested, and this was a little bit missing over the last year, the commitment of governments to really invest in here. Next slide, please. Now, if you look to the typical technologies and also looking at the usage, the liquid electrolyte alkaline named electrolyzer is commercially used for around 100 years. What has been changed now that all these processes, these electrolyzers get more compact, they get reduction in cost, they get more condensed. So just comparing with the solid electrolyte proton exchange membrane electrolyzer, which is around for 30 years, so you see a little bit the difference. It has higher cost, but as more renewable energy you will have in individual countries in the grid, as more you need a stabilization of the grid. And if you look at response time, proton exchange PEM electrolyzers can be and will be used as a grid stabilizer because they have a response time of milliseconds or seconds. So these are also different ways of using this. And not to forget, volatile renewable energy needs long time storage, and this is what also electrolyzers with bigger scale are around. The actual biggest electrolyzer has 10 megawatt now. The next one is planned 20 megawatt, and basically the 10 megawatt is instrumented with Endress Hauser, but it goes up to 100 megawatt and. So this upscaling and reducing of the cost brings much more project onwards. Just to name the third possibility, this is a high temperature electrolyzers with superheated steam, which is relatively new, some years out. Next slide, please. We have typical processes here. So every electrolyzer needs water purification, like in power and energy industry. You see here some blue devices. Typically as a skid or as a container, depending on the size. Then you have the electrolyzers module, here shown alkaline electrolyzer with a different components. And then depending on the usage, typically you have a hydrogen compression. Now it's a question where the hydrogen is going, if it's going to the grid, if it's going to a dispenser. But these are the main components, three components in an electrolyzer. Next slide, please. The cursor is still, this is one of our references. We have several more, but due to time we show only one. In our annual report of the Endress Hauser annual figures, we have an example from a hydropower plant, which then, when no really electricity is needed, puts electricity in this electrolyzer. This is 1.5 megawatt electrolyzer. It's not in container. As you can see, it's a small hall. But here, this is used for trailer filling, and afterwards, different industries like chemical take the hydrogen for the usage. And here you see exemplary certain instruments from us, which is typically one of our key assets, that we have a broad portfolio, and here everything is equipped with our instruments in this alkaline electrolyzer. Next slide, please. Already the summary to go into the discussion with you. By the way, on the right side, it was published. We have the first hydrogen power plant. If you go to the video, you can see it. The company is called Apex in Eastern Germany, and they have the whole power plant is based on the hydrogen supply. It's the first one, and here you see the heart, the electrolyzer, also with our instruments. Speaking with a lot of customers in the power and energy industry, but also in oil and gas, we always see that we can offer added value because we have a global presence. Look at our presenters or moderators today, USA, Netherlands, Middle East, and so we have a global presence and can offer industry networks to speak the language of the customer, which you see also here. We have a broad portfolio, not only at products, but also services and solutions. You saw some examples from the colleagues before in the skits and so on. And for sure, it always is important to speak fit for purpose. What functionality is needed? This is different in an electrolyzer. There are some critical measuring points, safety relevant, but there are also some basic functionality instruments. We have examples. We show you only some in competence in hydrogen. And one key topic is that always safety is a concern. So we have a Germany, it's called functional safety. We have a portfolio in terms of safety topics, not to forget hazardous areas which have to be covered, and already mentioned the heartbeat technology, which gives online or permanent monitoring and verification. This could be a topic to discuss. And finally, we can offer web-based document management, and we are happy to discuss standardization and support in your projects. This was it from my side. Thanks a lot.
Thank you, Rob. It's back to you, Rob.
Oh, great. Hey, thank you very much. I have some questions because that's the part of the session that we're gonna work on today as well. I also like to point out that in the handout, you can find copies of this presentation as well for you to download. And if you have further questions or you have a brain wave suddenly, and you needed to talk to an expert of Endress Hauser with regards to this topic, please don't hesitate to send us an email. Our email structure is really simple. It's first name, last name with a dot in between at endress.com. So jens.hundrieser@endress.com or rob.vermeulen@endress.com. And we'll try to help you as fast and good as we can. So I have some questions that were posted on the question tab as well. If you have some more questions, please do not hesitate to ask them as well. And I think the first question I have is for you, Jens. Jens,
yes.
Biohydrogen. Can you elaborate?
Biohydrogen.
Mm-hmm.
Yes, there are different ways of creating hydrogen. One is also acting regarding algae, and so there are a lot of different possibilities to create hydrogen. And what we show today is just one example. So at the moment, several projects show how hydrogen can be produced, green hydrogen, for the usage. Yeah.
Okay. I have also a question from Atta. Maybe I can give you that to you, Prasanth. Why wet steam detection is size dependent?
Yeah, it's a good question. Now we need to start to explain, why do we need to do the wet steam measurement? Now, if you have wet steam measurement conditions, means you have low efficiency in energy transfer because of the wet steam conditions, and you have lower energy when we talk about a saturated dry steam condition. Now, the reason why we are able to do this wet steam measurement is based on years of investments which we did on a steam rig in a place called Windisch in Switzerland, where we have been working with the university in terms of research and development. We have installed our meters under various dryness conditions. We have looked at how the signals are moving around under various conditions, and we have defined certain algorithms within the device and the samplings within the device, with the help of which we are able to do wet steam measurement today. At this moment, we have a limitation until 4-inch size today, but we are working on higher sizes.
Okay. Then I have another question. This is from Makole, and I think it's for you as well, Prasanth. Maybe you can give us a little bit more light on that one. What is the accuracy requirements for the hydrogen measurements in custody transfer applications?
Probably I'll direct this question to Arjan. Probably since we looked at this topic, can you explain this one on the accuracy criteria and the standards?
Yes, of course. Hydrogen, according to our custody metrology institute, so for custody transfer, is seen in 3 different ways. We have pipeline applications. Pipeline applications, it's at this moment seen as a natural gas. So that means you have to comply with the OML R137 or the MID MI002. We have the car applications within Europe, and as far as I know, also within the OML. This is dependent partly on OML R137, and partly it's also how the own country wants to give a certain message to it. That is, the local metrology can decide which accuracy needs to be fulfilled. This has to do with, if you go into the hydrogen application for your fueling stations, we didn't cover it in this presentation because it's quite complex process, especially if you have a buffer tank and there's 900 bar of hydrogen in there, and a car comes there with only 50 bar in his tank, then you have a pressure drop over the buffer, between the buffer tank and the car, of 850 bars. That pressure drop needs to be compensated. Simultaneously, you also need to cool the hydrogen, because the hydrogen is a noble gas and it heats. So you also need to cool it, and there needs to be certain algorithms. And in this way, you cannot always make it within the OML regulations. This is very complex. If you want to know more about it, I'm happy to tell more about it, to explain more about it, not here. Third part is the exchange of hydrogen as a feedstock for chemical and glass industry. At that moment, there are no regulations in place at the moment globally for hydrogen cells. I hope that helps.
I think that was a very elaborate answer, Arjan. Well, we're getting close. Let me see if we have some more questions. No, we have no more questions. So with this, I think we're coming to the end of this this webinar. I'd like to invite you again for next week, Tuesday or Thursday, same time, same place, new topics on oil and gas related process related issues or topics. And please please come. And I'd like to thank you for your participation and your questions and in your being there. You want to have some last words, Prasanth?
Yeah, thank you all the participants who has found time to join our session, and your continued support on our webinars which we are conducting since last many months. We have more interesting topics coming up in the coming weeks, and looking forward to connecting with you all. Thank you.
Arjan, some last words?
Yeah, I think most important is that this is just a very minor overview of all the applications and the challenges that lie within the applications around hydrogen. So if anybody has further questions, further topics or challenges, please feel free to contact us. We do have specialist people present to cover all the questions and challenges in your processes. Thank you.
Jens, last words?
Yes, thank you everybody for joining. And what I can say, there's a lot of transition, a lot of things ongoing, and this is also very dynamic, and we are there to support you. And thanks again, and wish you all, the most important thing is health in these times and every time.
You're addressing the hottest topic at the moment, Jens. Please be safe and stay healthy and take care of yourself. Hope to see you next week. And with this, I'd like to end the webinar. Thank you very much.
Thank you.
Thank you.
Thank you.